Alrighty, and we are recording. Welcome back to another video, guys. So I've been working on this new project for the last day and a half. Um, it's the weekend, so I had a little bit of time, free time, and instead of gaming, I decided to code some of the project. I ran into some pitfalls and new challenges, so I will be trying to face that outside of my classes. But yeah, I thought I'd start documenting my project idea. So a database. So if you guys don't know, and I can pull up, I guess I can pull up another tab and show you guys. Let me see. So here's the database. It's called Phoenix DB. Um, I don't know. I just like Phoenixes. I think they're cool. But if you guys don't know, I made a project a bit ago called Quick KB. And Quick KB is basically a key value storage database. It also supported files, so you could have persistence, but mainly it was a key value cache. So I wrote this. It got a couple thousand downloads on Crates.io for Rust. So it was, a few people liked it. Yeah, but I ran into some challenges that I realized were not that good for this database. So number one, um, I kind of implemented the client and there was no server for the database. It was only a client-based database. So that means you could only use this database in Rust. um, which is just not a good architecture for a database, I realized. Because if you're not using Rust, then you can't use this at all. And yeah, that's not good. So databases like, Postgres or MySQL, um, MongoDB, all of those, they have a sort of server that the database runs on top under and and the clients can connect to from any language, right? They have any sort of API, right? And this is pretty cool. This is pretty cool, right? The problem with this architecture, though, is that you have to have a protocol, right? You have to have some way for the clients to know, okay, here's how I need to send this data in my language so that the database understands it. And this is the problem that I'm running into when designing this because I'm trying to design it right. That's why I did it from scratch. And it's not really supposed to be complex. Like it's really like sort of my own Redis, you know what I mean? I'm just doing this to learn. This is a learning project for myself. Um, to work with data structures and all that. So yeah, I'll kind of walk you guys through the code I have so far, and then some of the challenges I faced. But yeah, let's go ahead and do that. So let's go to the code. So here's the code. It's a main file. So I do plan, assuming I finish this project actually, I do plan to make the binary by default a CLI. So, right now this is kind of like hard coded into this address and everything, which it will have a default address, but later on it would make more sense that when you install the binary on your system, you could just run something like, Phoenix start or whatever, like a command on in a CLI, and then it'll run and spin up a a CLI tool, which will just start the database on your system, and then maybe have a REPL as well for interactive database usage. But for now, right now, this just runs the database as a binary itself. So yeah, we pretty much set up a TCP. We're using Tokio. I wanted to just have concurrency asynchronous out of the box. There is no blocking client. Um, I want to get the database working first before I even try to make things more complex. I know it could be simple just to use asynchronous code, but I also just think that making it not necessarily performant, but I don't know. I just think async makes sense for this IO based type, database. Um, and also just having the features of Tokio to easily spawn tasks and threads and all that is just pretty good. Um, so yeah, we just set up a TCP listener. We bind to the port we set. And then right here is the struct I have, which is the database engine, which handles the connection, which is the actual database, which is just a hash map inside of a read write lock. And then the metadata is some other things about the database. I was thinking if this gets any complex, I would like to have like, a database configuration option. And then also like a username and password so that you could actually secure your database. Because I mean, if I did go through with this project all the way, it would be cool to like, just, cargo install, boom, the database on a Linux server, and then it can just start. doing what Redis does basically. And so yeah, having some password option in the future would be cool. So I just kind of put that data structure here. I'll show you guys the actual data structure code in a second, the protocol. But yeah, then we create this little channel right here. This is just for the threads, um, so they can send and receive, send basically manage the what is it called? The TCP, yeah. Sorry, my brain is a little fried. I'm like super tired. I haven't slept in like 2 weeks. But yeah, we can basically use this channel to like handle the TCP connection data and just make everything concurrent, and then we kind of loop through here and spawn. So handle connection is the next important step. So we're just going to go into that function. And as you can see, it's not that complex. We're pretty much just creating a buffer. I'm not sure how, like, I know I hard coded like this 32 is the channel limit, and then like the buffer size. I'm not sure what the consequences of making these like fixed, like if it's too small. I mean, I guess maybe it'd be cool if you could like customize this as the, person running the database. But like I said, all that's the complexity that I need right now. I want something that works first, right? Um, yeah, so if we go into TCP though, we can see that we have buffer, and then we simply read all the bytes in the stream. And yeah, so we handle the command. So we just convert the buffer to a string UTF-8, and that's how we grab what are we grabbing? Yeah, we're grabbing the name of the command, right? So that's like the first bytes being read. And then yeah, we're basically passing those bytes to the command handler, and we're awaiting that, right? And yeah, I think this just sends back the response to the stream, whatever. So let's go into this handler now. And this handler is pretty cool. So we have so we grab so basically I'll show you guys. So the structure of a command looks like this. So it's like insert, and then let's say the key is name, and then Jamal, right? So this is what this is doing, is basically splitting up the parts of the command. So if it's empty, which basically we grab, if it's empty, that basically means there's no command. So that's why we say invalid command. And then we grab the command name, which is the first element inside. So we take a string and then we basically convert it into an array of strings, which is what you see right here for this, right? And then that way we can easily work with the data. So yeah, we're grabbing the command name, and then the arguments is everything after the command name. So we have the key and value, and also type, I guess, but we don't really care about that right now. Um, yeah, we simply just pass it to the static commands. So here we can hover over this, and you can see I have a static um, sort of lazy map of all the valid commands in the database. I did this because I wanted to do a lot of things at compile time. So like once the binary is built, we kind of have the commands already set, and it's also just easier to work with the commands this way if we can have a sort of function to manage them, which I'll show you guys a little later. But yeah, we simply grab the name, and then we get the command, and then if it does exist, then we simply call that command function, and then we pass in the arguments, the rest of the arguments. So only the key and value and anything else will be passed. And then we pass in a pointer to the database, right? And we don't actually have to use like the pointer syntax, because this is an arc, which by default is like a shared mutable reference. So that's why we could just pass that like that. And then we await it because we're doing async code. So that's how that works. And just gonna delete that. And yeah, so we need to go into the commands. So let me show you guys the protocol. So here's the protocol of the code. This is basically just most of the types for the database. So here's the DB engine. We have the connection, which is the database, which is just a hash map. And then we have the metadata right here. And yeah, so we have the key, which is just a string. And then the value is basically, here's all the supported data types for the database, right? We have integer, which is an I64, float, text, which is a string, and then we have Boolean, we have list, which is an array or map, I mean, sorry, an array or vector. And then we have map, which is like hash map basically, and then void. Void is like the null or nil type. I just didn't really want to use null or nil. So yeah, this void basically means there's no data, but it's still it's a way it's a data type to represent no data types. That's what I mean. Um, and yeah, I guess like if there was a client library that connected to this, because the client also has to understand the protocol that it's reading. So this would just convert to like, nil or null or whatever is in another language. But for this data structure, I'm just using this data type naming convention. And then here we have a command function, which all the commands are linked to. And this is a function pointer, which takes in a vec of strings, which is again the same as this. It's a vector of strings, right? So it takes in all these arguments from the parts, and then it takes in a pointer to the database, and then we return a box future because it's asynchronous, right? So let's go to one of the commands. So here is the lookup command. This is pretty much like how you get data from the database. And so we have a little usage thing here. This is mainly for like the CLI in the future. When like you use the CLI, I can like return some error messages. But for now, um, it's whatever. Um, and then let me see. Yeah, and then we simply just, read the hash map, and then we grab the data. We get the first argument, which is the key right now. And yeah, if we have that data, we just print it out. So later on, I will I have to figure out a way to like pipe this data back into the calling client library. But for now, it just prints out the data because that's the easiest way to test everything. This is one thing that's kind of interesting because as I'm doing this, I'm realizing like how complex, like I already knew databases were complex, but it's just kind of annoying to like try to support many different formats. Like SQLite, for example, is coded all in C, right? And there's no server for SQLite, right? So how do multiple languages use SQLite? Well, they just write bindings to like actual C code, right? Like the JavaScript would call C code under the hood. And that's like really cool because imagine having a server. Like it's so like there's so many like things that can go wrong with having a server. Like imagine the load on your database and stuff versus just calling like a client library. It's so simple. But I'm up for the challenge. And then this is just a function to kind of format everything, right? So where most of the magic was happening before I got frustrated and decided to record a YouTube video about this was in the insert command. So the way this worked originally, because I kind of deleted most of the code, just so that I can actually show you the guys the database works, like my code works. Um, Let me actually run this. Yeah, so we can run that and we can go to this Python. I have this little Python code right here, which simply just connects to the database. So this right here was the original way, my idea, right? So the problem I ran into was that, okay, insert, like let's look at this, right? This is the like original code. It was like insert, the key, and then value, and then the type of data, right? So int, float, text, bool, list, right? And then um where is it? Where's the protocol? Yeah, they match up with that, right? And then in the insert function, we would simply check the data type. But the problem with that, the big, big, big problem with that is that imagine you have a value that, for example, like a list, like look down here, right? This is a list. So if we separate this list by commas, okay, that works for numbers. But what about if a user has, some text, like a paragraph on an article they want to save in the database? It could have anything in it, right? So it's like, how do you parse this command when you literally have data in your command that could be any character? You know what I mean? So like that's kind of one of the main problems I went into. And my first original thought was like, okay, well we can do the command name and then we can use some type of like tags like X or like what is it called? XML, right? Like this is the type, and then we have the value inside, then we have the key, and then the value inside, and then, I guess because the type of this would be list, and then this is like items, right? And so you have items, then inside that is an item, and then you would have multiple items inside of items, right? And yeah, this just turned out bad too, because then I thought, okay, well, what if someone wants to save XML? So this whole thing would just break, right? So Yeah, this is kind of where I'm at. That's why the insert is like, well, there was really no code in here. I just had like a to do macro, but then I did this just so I could show you guys this code runs. Like if I run this code, you can see right here, insert, okay. If we look it up, nothing comes up because this doesn't work. But we can insert into there, 123 int, and then we can grab all the data, and you can see that it's all a string, right? Like it comes back as a string. It's just because of the format function from the lookup code, right? It pretty much stringifies everything, right? Um, yeah, so one of my ideas now was like I was looking at how Redis does it, and it appears that they use some kind of like frames and like, binary message passing and stuff like that. Um, my first thought was I could just copy the code, but I kind of wanted to make this my own thing, my own sort of database, my own little stupid project that is clearly not going anywhere. So I'm gonna figure out my own way. I think so. Two things, right? Either one, I could use binary, make some kind of binary algorithm or some kind of like binary protocol, or I could just be lazy and use Serde and just just like format everything to JSON and then pass everything in JSON, and then I could use the data structure of JSON between multiple, sorry, I hit the burp, between multiple languages, right? And that's kind of where I'm leaning. It's not the most performant thing in the world, but if I use JSON, right, then I could just have something like, like a struct, and it could be like let's say JSON, right? And then it's like, the type of data, which could be like, anything, right? Or no, I guess it'd be like DB data, right? And then we could have, the value and then um the key, right? Like this could be the data that's well, maybe not the key because, but like as long as we know the data type and then the actual value of what we're storing, we could uh we could reply to the client, and then the client side would simply have to know the data type and then create whatever necessary data structure it needs to pass it back to the code. So that's kind of what I'm thinking. Serde just might be my easy way out of making all this work really seamlessly with a TCP server. I'm still thinking about it, but I'll let you guys know how it goes. This video is kind of long now, about 17 minutes, so I'm not gonna run it any longer. But yeah, that's my database idea. Um, I guess I could show you guys. Did I actually? Let me see. Really quick, I'll show you guys my how I did my first database. Um, I'm pretty sure I don't even remember writing some of this code. Okay, okay. Oh wait, it's in here. Um, yeah. So we had like a state and writer reader. Okay, yeah, because this was file based. Yeah. So I believe where's the state from? The state is in the state. Okay, that makes sense. Yeah, so here's the state and we had entry. Okay, yeah, so I actually copied most of this code right here from the Rust, sorry, the Tokyo like example, because they had basically like a miniature Redis example, which is one of the reasons that got me interested in making this in the first place about a year ago. And I sort of just copied this code, which is just a hash map, and then it has the entries right here. Um, and this is basically sort of this just stores data as bytes, I believe. What is actually T? I guess it can be anything. See, this is one of the problems, right? Like it's not storing, it's using Rust data types. Like there's no way like storing data as T doesn't actually make sense because like how is another language supposed to read that or use this structure, this data structure? It's impossible. Um, so yeah, I'm thinking just using Serde to convert JSON to parse it. And then if I make a JavaScript client, like JavaScript has built-in support for JSON, so that'd be super easy. Um, but yeah, and I'll probably also use I think one of the dependencies I have in here is yeah, I have bin code as well to like convert the code to binary as well. So yeah, we'll see. We'll see. But yeah, that's pretty much the video, guys. Sorry for the rambling, but I hope this video was interesting, and I'll continue updating you guys whenever I have time later. Oh, and feel free to start the project if you want. It is Here's the repository again. I'll leave it in the description, but yeah, here's a repository. Start if you want. Peace.